There's 6.4 homework on conditional probabilities. So in number 1, it says, first make sure to underline the two events in each problem and label them A and B. And so in number 1, we have a die is rolled and a coin is tossed. So now remember, these two are actually independent events. There shouldn't tossing a coin shouldn't change the probability of getting, say, a 3 on a die. And so what we want to do here is underline event A. So find the probability of rolling an even number. Right. So here's an even number. That's event A. And means intersection. Tossing a tails. So tossing a tails is event B. So this is saying find the probability of A intersect B. Because we know these two events are independent, we can use the formula P of A times P of B. And P of A is the probability of rolling an even number. Since there's 3 even numbers, right, 2, 4, and 6 out of 6 possibilities, so we get 3 6 for probability of A, times the probability of B, which is tossing a tail, so 1 tails and 2 possible outcomes, so 1/2, which is equal to 3 over 12, or you could write this as 1/4. Right, so the answer is 1/4. Right, or, of course, 1/4 is 25% of the time. You would expect to roll an even number and get a tails. Now we want to find the probability of rolling an even number. So that's our event A. Or, right, which is the union of tossing the tails. So that's our event B. So find the probability of A union B. Again, we can use our formula, which is different than the one above because it's union. So P of A plus P of B. And then we have to remember we probably counted that intersection twice, so we have to take it off once. So probability of A intersect B, which is equal to, so the probability of A, so probability of rolling an even number, right? There are 3 even numbers again, 2, 4, and 6, divided by 6 possible outcomes, plus now we're tossing a coin, so the probability of tossing tails is 1/2, minus the probability of rolling an even number and tossing tails, which we found above here, which was 1/4. And so to figure out this, we need to find a common denominator. 12 goes into all of these, so we multiply here top and bottom by 2, so we get 6 over 12. Plus, here we can multiply top and bottom by 6, so we get 6 over 12 here too. Right, so these are actually the same thing, huh? Well, that's okay. Multiply top and bottom by 3 here, and you get 3 over 12. And so what we have is 6 plus 6, which is 12, minus 3, which is 9 over 12, which can be simplified to 3/4. And so our answer is 3/4, or we can write 75% of the time here. All right, so 3/4 of the time, I'll either roll an even number or I'll toss a tails. In part C, now it says find the probability of rolling an even number. That's my A. And then given that, right, that's my line, the coin landed on tails, and so this is my B. So I want to find here is the probability that A occurs given B has already occurred. And I can look again for the formula. It's P of A intersect B, all divided by P of B. And remember where this formula comes from. If you think about the Venn diagram, and assuming B occurs, what happens is just the circle B lights up and everything else goes dark, and then you just have this little intersection, A intersect B, which is part of A. So you take the probability of A intersect B and divide by the probability of B. We've already found these numbers. The probability of A intersect B was the first thing we found. That was 1/4. Divided by the probability of B, which is tossing a tails, which is 1/2. And so this is equal to 1/4. You multiply by the reciprocal, 2 over 1, and you see you get 2 over 4, or the same thing as 1/2. which is 50% of the time. Now, you could have done this part of the problem without even knowing the rest of it, because you'd say, okay, well, what's the probability of rolling an even number given that you threw a tails? You toss a tails? Well, the tails doesn't matter, right? So it's just a probability, basically, of getting an even number. There are 3 even numbers. There's 6 choices, so 3 over 6, or 1/2, which is 50%. And so that's the idea. Let's look at number 2 now, which is kind of similar. All right, so now we have a card is drawn from a 52-card deck. Find the probability of getting a heart, that's A, and, which means intersect, a red card, B. Right, so find the probability of A intersect B. Now for this one, I'm not sure if these are independent or dependent events. It's not as obvious. It's not like tossing a coin or throwing a die. So what I'm going to do is think about this a little bit. So getting a heart and getting a red card. So if you think about the pictures, actually, over here you have 52 cards total, and then you have all the red cards here. So here are all the red cards. And inside the red cards, you actually have all the hearts. Right, so there are 13 hearts here. And over here, there are 13 other red cards to give you a total of 26 cards. So if I want to figure out the probability of A intersect B, I'm going to go right back to the definition of probability. So I take the number of things and A intersect B. Right, so this is like my A, right? And this is my B. Divided by the number of things in my sample space, S. The number of things in my sample space, well, there are 52 cards total. And the number of things in A intersect B, now you have to realize A intersect B is actually all of A, because A is contained inside B. So this here, in blue, is A intersect B. And so what we have are 13 things. And that makes sense if you think about it. Okay, you have a heart and a red card. Well, how many hearts do you have? 13. They're all red, so you have all 13. Right? So you have 13 over 52, which is actually equal to 1/4. So 25% of the time, you'll draw a heart and a red card. 25% of the time, you'll do that. Next one, find the probability of getting a heart, that's A, or a red card. So that's B. Right? Or means union. So find the probability of A union B. So this is equal to, if we use the formula, P of A plus P of B minus P of A intersect B. And so this becomes real simple. The probability of getting a heart, well, there's 13 hearts divided by 52 cards, plus the probability of drawing a red card, well, there's 26 red cards divided by 52 total, minus the probability of A intersect B, which we found above, was 1/4, or we can just say 13 over 52. And so we see that these two terms will cancel because they're the same number and you're adding and subtracting. And so you get 26 over 52, which equals 1/2. So 1/2 of the time, or you can say 50% of the time. And this actually makes sense if you think about it. In A union B, how many things do you have? Well, here's A, here's B. You just have 26 things, so 26 over 52, and you get 50%. Now we have the probability of getting a heart. So that's my A. Given that, so that's my line here, the card was red. So for this one, what we want to do is we write down the probability of A given B, and that's equal to, we look at the formula and you get the probability of A intersect B divided by the probability of B. And we already found the probability of A intersect B, it was 1/4. And all divided by the probability of B, which is the probability you draw a red card, which is 26 over 52, which is equal to 1/4. We multiply by the reciprocal, so 52 over 26, which equals 1/4 times 2, because 52 over 26 is 2, which equals 1/2. Right? Or we could say 50% of the time. And again, if you think about this, it's pretty obvious. What's the probability that you get a heart given the card was red? Well, if you limit yourself to red cards, there's only 26 of them. And how many are red? Well, 13. So you get 13 over 26, which is 1/2, right? 50%. On the next page, on number 3, it says 4 names are in a hat: Jimmy, Steve, Susie, and Julie. Find the probability of drawing a name that starts with S. Okay, so here is our letter A, and, or even A, and means intersect, female. So this is our event B. So you want to find the probability of A intersect B. I'm not sure if these events are independent or dependent, so I'm going to have to go with the old definition. The number of things in A intersect B divided by the number of things in my sample space. Number of things in my sample space is simple. There's 4 names, so I have 4 things in there. And I want a name that starts with S, so there are 2 of these, and is female. And so that crosses out Steve. I'm assuming Steve is actually male, and it just gives me Susie. So 1/4. There's only one thing in A intersect B. All right, so probability is 1/4. I'll draw a name that starts with S and is female, right? Or we could write 25% here. Now we want to find the probability of drawing a name that starts with an S. Right, so there's my A. Or, so that's union, is female. So now the probability of A union B is equal to the probability of A, right, plus the probability of B, minus the intersection, the probability of A intersect B, because we counted it twice over here. And so this is equal to, right, the probability of A, so probability that a name starts with S. Well, there's 2 names that start with S, so that's 2/4, plus female, so Susie and Julie here. Right, Susie and Julie I'm going to assume these are the only 2 females, so that's also 2/4. And then I have to take off their intersection, which was minus 1/4. We found that up here. And so that's equal to 3/4, right? 2 plus 2 is 4, minus 1 is 3, so 3/4 of the time. Or we could write 75%. All right, let's move on to the final one here, part C, to find the probability of drawing a name that starts with the letter S. So there's my A. Given that, the name drawn was female. So find the probability of A given B. Again, we can look at for the formula, it's probability of A intersect B divided by the probability of B. And we can fill in these things here. We already found the probability of A intersect B, that was 1/4. So you write 1/4 here, all divided by the probability of B. So remember, B's, you draw a female name. There's 2 female names and 4 total, so 2 divided by 4. And so we get 1/4 times the reciprocal of 2/4, which is 4/2. The 4's cancel, and you get 1/2, or 50%. Now, we could have figured this probability out without even using this formula, because we would just say, okay, well, let's assume that the name was female. So what that does is that eliminates these 2 cases, Jimmy and Steve, and we have 2 cases left. So we know it's either Susie or Julie. What's now the probability that you start with an S? Well, that's 1/2. All right. So let's go to the next one here, the very last one. And now we have 3 red cards are numbered 1, 2, and 3. So let's draw a picture here. Let's draw some red cards. Right. So here's my red cards: 1, 2, and 3. And 3 black cards. So let's get a black marker here. So black cards are 4, 5, and 6. The cards are placed in a box and 1 card is drawn. All right, so we want to answer these questions. So now find the probability of drawing a black card. That's going to be our A. And, which is our intersection, an even number. So that's going to be our B. So find the probability of A intersect B. Again, I do not know if these events are independent, so I have to go back and say, okay, let's just do the old standby. The number of things in A intersect B divided by the number of things in my sample space. The sample space is easy. There's just 6 things. There's 6 cards. And then I got to figure out, okay, well, how many of the cards are black and an even number? All right, so these are all black, and this one's even. All right, and that one's even. So I get 2 things in A intersect B, right? 2 cards that are black and also even, and that's equal to 1/3, right? Which is about 33% of the time, so or 33%. I'm going to go with 1/3. Now I want to find the probability of drawing a black card. So there's my A. And, oops, that should not be there, right? So, or, right, this should be union, so that and should not be there, or an even number, right? So that's my B. So this one, like all the other ones, is asking for probability of A union B, which I know how to compute. I just use the formula, probability of A plus probability of B minus the probability of A intersect B. And so that's equal to, well, what's the probability of drawing a black card? Well, there are 3 black cards and 6 total, so 3, 6. Plus the probability of drawing an even number. Now notice there's 1, 2, 3 even numbers, so plus another 3 divided by 6 total. And then minus the intersection, which is 1/3, but I'm going to write this as 2, 6. That way I don't have to worry about finding a common denominator. And so 3 plus 3 is 6, minus 2 is 4, so we have 4/6, which is equal to 2/3 of the time. Right? Or you could say 67%, but we're going to stick with the fractions. All right, so probability that I draw a black card or get an even number is 2/3, or 67%. And then the final problem involves our conditional probability. So find the probability of drawing a black card, that's A, given that, that's the line, the number on the card was even. So find the probability of A given B. So to do this one, again, we write down the formula, probability of A intersect B divided by the probability of B. And we come up here, and we've already found the probability of A intersect B was 1/3, so you write down 1/3, divided by the probability of B occurring. Now the probability of B, right, B is you draw on, the card was even. Well, there's 3 even numbers, right, 2, 4, and 6, and again, there's 6 possible. So this is equal to 1/3 times 6/3, which is equal to 6 divided by 9, which is 2/3 of the time, right? Or 67%.